Hi guys, this is Manik. Welcome to the second part of our video series Deep Learning Studio. In this video, we'll create an AI which will be able to detect 10 different types of objects present in the image. We are going to use Deep Learning Studio for this task and we'll learn step by step while doing how to use Deep Learning Studio actually to create such type of AI. So yeah, let's get started. So let's start with opening our Deep Learning Studio, app.deepcognition.ai/app. So the first step, create a new project. Click here to open the project. Now, the first step for any kind of deep learning project is always the data. So the data set which we are going to use here is CIFAR 10 dataset. It consists of 60,000 images of 10 different types of categories, where particularly for each type of category we have around 6,000 images. So yeah, for this task, Deep Learning Studio has already provided a CIFAR 10 dataset in their public dataset. So yeah, you can just directly select it. So this is how you need to select the dataset, CIFAR 10. Okay, now this is the training and validation. That is what percentage of data you want to use as training data and what percentage of data you want to use as test and validation data. If you use 80-20 ratio, 48,000 images we can use as training data and 12,000 images we can use as validation data. So yeah, now shuffle the data. Shuffling is very important because if particular types of images are present together, then it will just shuffle the data so that all types of images are present in training data and validation data and test data too. So yeah, another most important thing in deep learning is normalization. We need to normalize our images. Normalization here means that each of the pixel in the image is divided by the maximum value of the pixel present in the whole image. That is known as max normalization. Otherwise, we have even other types of normalization where we could subtract the pixel from the minimum RGB value present in the image and then divide it by the maximum minus minimum. That is divided by the difference of maximum RGB value minus minimum RGB value of the image. So yeah, and even normalization helps in training the model faster. That is, if the data is normalized, then it is easy for optimization algorithms to learn from the data. So yeah, the next important step, model. Now we need to design our model. This is the best part of Deep Learning Studio because there is no need for any one of us to write any code. We can just drag and drop the layers. So yeah, the first one is the input layer. Let's drag and drop the input layer here. It will show the dimension of the input. Here 3 refers to the 3 channels present in the image, that is RGB, and 32 by 32 is the dimensions of the image. Now we'll follow a general architecture of convolutional neural networks. That is, most of the famous papers use a particular type of architecture such as convolution, and then there's a max pool layer, and then there's a dropout layer, and then they repeat such type of steps again. So we'll also do the same thing. Well, you can try out with different architectures and you can check the accuracy of your model. So yeah, let's go with the basic stuff. Well, input, now convolution. This is the size of the filter. Well, number of filters could be 64 in the starting, and size of the filter is 3 by 3, and as usual we can use our rectified linear unit as our activation function. Now convolution. Now there is another layer of convolution. So yeah, same thing we can do there, 64, and one thing which we can do is here we can change the padding type. That is, from valid we can keep it as same, so the dimensions will not decrease due to convolution. Well, we have just added padding to our convolution layer. Now let's go with max pool layer. Where are the pooling layers? You can just drag and drop everything and it's quite easy. Now just connect them. This is the thing. Select the pool size of the max pool layer. And finally there is a dropout layer. For dropout layer you need to pass the parameter fraction to drop. And even dropout layer also works as regularization layer up to certain extent. So yeah, next thing, we can just continue with the same pattern again. If you double click on any layer, you will just have a copy of it on the board. So you can, instead of dragging and dropping again and again, you can just double click on them. The same parameter, we can change the number of filters to 128 filters, and same activation function as reloop. Come on, I guess the size is fine now. We can just use max pool now. Pool size of the max pool 2 by 2. Now we have enough parameters, I guess. Now we can use flatten layer. This is flatten layer which can be used to change the dimensions of the output into a single dimensional array. Now come on, densely connected layer, and densely connected layer is our fully connected layer. Here we have to pass the number of dimensions in our densely connected layer. So let's take the dimensions as 512 and activation function as reloop again. Now we can use dropout layer. Dropout prevents overfitting of the data, and we can pass the fraction of dropout at maybe 0.25. You can try out with n number of hyperparameters which you want. You have seen here we have hyperparameter, filter rows, filter columns, if padding must be there or not in the convolution layer, or max pooling layer, what should be the pool size. You can just try out with n parameters and you can just check which one works fine. And this is what deep learning researchers do. They try out with different number of hyperparameters so that they can find which one could work best. Now dropout is there. another densely connected layer. And in this densely connected layer, we need to pass the output dimensions equivalent to the number of outputs which we want. And finally, we generally use softmax function, which will give us the probability of each of the class present in our data set. Well, for most of the time, the highest probability will be for the class which is present in the image. So yeah, after densely connected layer, we can have just our output layer. If there is any mistake in the model, then you will see a red mark here. That is if it is not connected or if the parameters are not right. Now it is fine. There is a tick. Okay. Now hyperparameters. Come on, number of epochs. You can choose any number of epochs. Well, I'll just go with 10. Optimizer. You can use any one of the optimizers, and it completely depends on your dataset which optimizer would work fine for your program. But generally, what I have seen, Adam optimizer works fine for most of the things. So yeah, these are the parameters of Adam optimizer which you can change and check which one is working fine. Now comes the training part of a model, and the most important and the most interesting and the most time-taking process in deep learning. So yeah, the first thing which we need to do is start an instance. So Deep Learning Studio provides you 2 hours of free NVIDIA Tesla K80 GPU. So you can just click and start here, start the instance. Now let our instance get started. These instances are directly AWS virtual machines, and I know it takes a lot of time even for AWS machines to start. So yeah, our instance is started because it's in green color now. What do we need to do now to start the training? Just press the start training button and it's done for us. Our model is getting trained. We have around 26%, 30% accuracy right now. Well, you can see the live accuracy also here. Here, 37%. And you can see the complete graphs now. This is a good feature actually, because you can visualize loss and the accuracy simultaneously. So if your loss is increasing, that means there is some mistake in your model, or if your accuracy is not increasing. The estimated time is shown as around 10 minutes on this NVIDIA Tesla K80 GPU. Well, 12 GB. This is the run name. If you type some name here, then with that name, the output or the results of this model will be saved. Load previous weights. We can even load the weights from the previous model, but that model also must be trained on the same dataset and with exactly same architecture of the model. So that means similarly, like if you try to train this model again, then you can load for that next model, you can load the weights of this model, and that's how it will work. Another advantage of this load previous weights is there is no need for the model to start learning from scratch. It will learn from the point where the previous model has stopped. So that's how it works. There is no need for the model to start from scratch. So yeah, did you see the accuracy on the validation set? It's around 66% after the first epoch. Epochs means the number of times we want our model to train. While training is going on for our model, let's see some other features of this Deep Learning Studio. This is the inference and deploy model. So if you want to deploy your model, that is if your model is created and now you want to deploy it for some purpose, then you can just directly select the training run. Here training run means this name which we have set here. Training run means this. So run 0, run 1, that's how you can select them. And then after that, you can just select that training name, service name. You can just give any service name, and then you can deploy a model. A web API will be created for you, and which will work until you turn off your instance. You can even download your model from here. After your model is trained completely, you can just download it and you can import it. Like if you want to use it somewhere in your server, then you can easily use it. So that's how it works. Well, if you want to visualize the results of any previous model, then you can select that model here, and then you can check everything here, that what was the accuracy and how much of the data was used and what is the training loss and all that stuff. You can see all kinds of details here, the samples used and what amount of training data and what was the testing data, what was the architecture of your model, what were the hyperparameters and what was the name and blah blah blah, and weight saved on, like on every epoch or whatever it may be, or load weight, like from which model did you import the weights. So yeah, that's how it works. Well, it's gonna take around 18 minutes of time, and of course I know we can't wait for that much time, but this is our validation accuracy, that is 71.83%, and 76% is our training accuracy, that is on that spot. So I want you guys to definitely check out this Deep Learning Studio and create your own model and complete this training, and let me know what was your accuracy in the comments below. So yeah, thanks for watching.